Okay, now another prominent theme that wasn't in here that's going to be in trig is finding the x and y intercepts of a graph of an equation without actually graphing it. Now, here's what you're going to do. You're going to kind of make a column. You're going to put x int intercept and then y int. Okay. Now, sometimes there are more than one, and you put parentheses, okay, with x, y, with a comma, like it's a coordinate. Now, sometimes you need more than one of them. Now, look at your y. Your y is not to a power, so it's just 1. But the x has a second power, so I would look for 2. Now, the y-intercept's really easy to find. You put 0 in for x, okay? And since the y is by itself, you basically just solve that on your calculator. It's probably -1, I'm guessing, because 0 to the second 0 minus 1 is -1. Yep. Okay, and that's your y-intercept. That's easy. Okay. Now your x-intercept, you put 0 not under the x, but you put them under the y's. And what you do, you have to do a little bit more work to find the x-intercepts. Not a lot, but just a little. Okay, so 0 takes the place of the y, and then x to the second minus 1. I just get x second by itself, okay? I don't have to factor this. I can just get that by itself and square root it. Okay? Oops, sorry, 1 equals x. It doesn't matter the order you write it. Now you do your square root. Now the square root of 1 is 1, but it could be positive or negative, okay? So you put 1, -1, okay? There you go. Okay, next problem, x int, y int. Now let's check out the y int. Y is just to the first, so there's only one of those with the x at 0. X intercepts to the second, so there's 2 of those. Again, you put the other letter. This is the x-intercept, so we want to replace the y's with zeros. At the y-intercept, we replace the x with zeros. That's going to be how you format it every time. Okay, y-intercept, do that one first. That's easy. So y equals 0 to the second plus 4, and it's 4. Here's a news flash. The y-intercept's usually the last number without the x. Okay, now the x-intercept, y becomes 0. Okay, and then you subtract 4, and that is -4. But I'm about to square root a negative number, which leads me having to do I. And when that happens, you have no x-intercepts. Okay? Now you're like, well, how could that be? Well, easy. That's a parabola. Draw this here. But sometimes a parabola could be right here. Does that ever cross the x-axis? No, it does not. So it would be something like that. Okay? Crosses the y-axis here, but that's why you always have a y-intercept. But it never does make it to the x-axis. It's everything's above. Or if it could be this, okay? Never makes it across the x-axis. That's why that I, it's a deeper meaning behind the I. Okay? You just remember when you square root, if it's I, then it's not going to exist. Okay, again, the y is to the first, so there can only be one y-intercept, 0 for x. X is to the second, so if there are intercepts, I'm looking for 2 of them. Okay, so put 0. Replace the x with 0 because it says x is 0. That's 6. Okay. And then I'm replacing my y's with 0 so I can solve for x. So 0 equals x second plus 6. To find the x-intercepts, I got to do a little bit of work off to the side here. Okay, again, you're going to end up trying to find the square root of a negative, which means the I, and that's an imaginary solution, so that won't show up on any graph, so these don't exist. Okay. Next up, X int, Y int, 0. And then there are two X's. And then we put zeros in for the Y's. Now, the X is easy to replace with 0. Because I don't have to undo any operations. I just solve it. Okay, that's 0 minus 9 is negative 9. Now you're like, wouldn't that be not existent? No, because I'm not square rooting negative 9. The Y is not to the second power. Then 0. And I got a positive, so I know right away these do exist. Okay, so square root of 9 is 3, or it could be negative 3.